As Jesse mentioned, my name is Brad Gipson. Thank you all for this afternoon. Today we'll be presenting on how I manage and how you can manage a high availability Lustre environment using multiple namespaces. So first off, a little introduction. Who am I? Where do I come from? So I come from Oak Ridge National Laboratory, and I actually operate under NCCS. NCCS stands for the National Center for Computational Sciences, and we operate underneath Oak Ridge. Oak Ridge has multiple different directories under it for neutrino sciences, computational sciences, et cetera, et cetera. It's a very diverse location, but NCCS is our computational division. One fact about it is that within NCCS, we actually have separate divisions within it. The most important and largest one, I would say, is our Department of Energy based division, and that is the Oak Ridge National Lab Leadership Computing Facility, or just shortened for OLCF. Mouthful. That runs our larger leadership computing facilities, such as Frontier, Orion, Summit, Alpine, most of which you've heard of the past few days here. And that usually gets our most attention, but lesser known, but still as important. As the DOE runs Oak Ridge National Laboratory, we also do strategic partnerships with other government organizations, some of which include NOAA. So we have a organization with NOAA partnership known as the National Center for Computational Sciences. This is where we run our C5, C6 computational programs, our F5 and F6 file systems. Additionally, we have Air Force Weather, which I am a part of, where we run different file systems, which I will be talking about today, and a couple of different compute systems. We have many other different programs as well. And one thing to note is that while NCCS do support these different partnerships, they are all the same individuals, right? So we work with the OLCF and these different partnerships. So you'll be seeing examples like me working with Air Force and Orion, who will be working between these different programs. Additionally, all these partnership programs are research-based. So as you may be able to tell, right, it's NOAA. You get your weather from them, and they do a lot of research based for climate. So we have two different climate-based. We have NOAA for climate and Air Force Weather for climate as well. So those are the two focuses for our different programs. So getting into it a little bit, some of the overview for our Air Force Weather program. We have two separate file systems, Storm and Cyclone, going with a little bit of the weather theme, right? They are both running Lustre 215, and we have an additional matching TDS named Gale, continuing with the theme. Each file system contains 7 petabytes per file system, and you can see them pictured on the right for our capacity. They are composed of DDN SFA 14KXs and have about 840 drives, approximately 840 drives of 12 terabyte PMR drives. It's important to note that our TDS is a matching size. So that is very nice. It's pictured here. If we had it here, it'd be looking exactly the same. So kind of a boring picture. Additionally, we have metadata for all of the file systems. They are 110 terabytes in size and are using DDN SFA 200 NVs using 77 terabyte drives. On the back end, we have 2 redundant 100 gigabyte HSNs going between our file systems and compute. So that's a SAN. Breaking down our physical attributes for our systems, we can see here that we have pictured on the right are cabinets that you saw on the previous slides, but additionally, what was not pictured, we have our management stacks, our metadata servers, and our spare nodes. And looking a little bit more in depth on how we have those set up, you're going to notice a lot of even numbers on the left side of the slide here. So we have 2 MDS nodes with a single MDT per node, 6 OSS nodes with 2 hard drive OSTs per node, and a singular MGS node. And getting into some of the reasoning for this, right? So we have 2 MDS nodes with failover for a single MDT, right? So we can lose a singular metadata server and still have our clients have access to our MDT. Additionally, our OSS nodes have a similar philosophy where if we have failover of a single OSS, it has a partner node, so a client can access up to 4 OSTs from a singular OSS node. Each file system has its own MGS. So take down a file system, and MGS is still available for the opposing file system. This philosophy carries over into our management stack. So we have 2 management servers with redundant management stacks. So if we lose one, we still have that transfer over to the sister file system management stack, and for utility servers as well. So keeping that throughout the entire stack, right? If you lose your management stack, you can still lose your file system. If you lose critical services such as like DNS, DHCP, etc. So keeping that going all the way up and down. And additionally, we have miscellaneous hot spare nodes. So most of our nodes for OSSs, MDSs, and management all are Dell nodes. So we just keep a couple warm just in case if we have any hardware failure, we can pop in and out and keep right on chugging. So getting a little bit into the HA overview. Again, as I mentioned, we have 2 separate namespaces. We are not conjoined into a singular namespace. So again, Storm and Cyclone. So we can take one down, keep one up. One important key factor is we are identical in shape, size, and configuration. So the key aspect with this is that if we were to have a file system with a separate or smaller size, we could run into issues with our replication, which we'll go into a little bit later. And we would potentially run into capacity issues with replicating that traffic onto the other file system and be unable to fully replicate all the data that we need to. So making sure that they have equal amounts of size is critical. And additionally, configuration, being able to ensure that we have a clean configuration across both allows us to ensure that we are keeping our stack the exact same, and that our users are going to experience the same exact when transitioning between both file systems, and it'll help us a little later, as we'll discuss. Moving into the redundant management stack, as I mentioned, if you lose your management stack, you're possibly going to lose your cluster, no matter how redundant either file system is. So keeping that redundant and allowing failover there as well helps to keep our namespace up and running. One of the most important facts, and we'll get into how this works, is replication between namespaces. So this will keep data going between both Storm and Cyclone. So we can take a namespace down and allow our users to ensure that their processes are going to keep running and they're going to be able to complete workloads on that Lustre file system. And additionally, we have dual homed Lustre hosts. So while we have 2 Lustre file systems, we have 2 networks, we have 2 compute units. We're pretty redundant in a lot of aspects of our environment. So while not completely necessary, it's a big part of making sure that we keep operations running. So some design considerations. As I mentioned, again, making sure that both are the same capacity. Getting a little bit more into the same, into our configurations. So having the same configurations has some additional benefits. One of the key being our upgrade paths for Storm and Cyclone. So while we are able to take down a file system without the users really being able to have any critical notice or being able really to tell, having that configuration similarity between both file systems ensures that we're able to create these upgrade paths for either file system that reduce the amount of downtime for either file system and keep a clean configuration. This also ensures that if we do encounter an error within our upgrade path, that it's an error due to possibly hardware or firmware and not an issue with our upgrade path, right? So it keeps things very clean, very fast, and helps to ensure downtime of either leg of our file system configuration. Additionally, one of the, if not the most important aspect of it, is our environment-aware user-level replication. Now, what do I mean by this? So one might ask, why don't we do replication across both file systems, file system-wide, right? We choose, in our case, to have file system to have replication managed by the users themselves. This has a couple different benefits. First most being that the users are able to do replication when they need to, right? So if we were to do replication as ourselves across the file system, then we wouldn't be able to perfect timing with the user's jobs. So if we were to do replication and it were to interfere with the user's jobs and perhaps cause slowdowns, that could cause trouble, right? Especially with it being a weather-based research system. that could cause issues. So the users now are able to control when replication happens and allow runtimes to occur and end when they need to. Additionally, one of the better benefits is that we don't have to replicate everything, right? So we do have some pretty good users, and they determine what does and does not need to be replicated. Instead of replicating literally everything and having all the traffic bound over, if they only need to replicate 1/10 of the job traffic, they only replicate 1/10 of the job traffic. Or if they only need to replicate 1 job or 2 jobs, they only do 1 or 2 jobs. So we're able to significantly reduce that overhead for our job replication and total data replication between either file systems. So it's pretty good. We really do enjoy that aspect of it. Additionally, to support this, we have local data transfer nodes between either file system with data transfer queues. So when users want to transfer data over between file systems, they send a request into a data transfer queue. Currently, this is using Globus, and that data transfers, those data transfers are then executed using local data transfer nodes to either file system. Now, this can cause some issues if a file system is down, and those queues will build up, right? So those queues will be held if a file system is down, but we'll discuss how that can be kind of solved here in one of these future slides here. Additionally, we have redundant high-speed network links. While this is not necessary, it is highly recommended. Keeping as much of the stack as possible, as redundant as possible, helps to keep operations up and going as well. So that's additional benefit. So looking into some of the workflow management, how does this look from a user's perspective, right? So if I were a user and I was on the system, I would ls/Lustre, and I would see Lustre Storm, Lustre Cyclone, and a Lustre Active. So on either Storm or Cyclone, we have a listing of all the project IDs and in their entirety. Additionally, in Lustre, if you list out Lustre Active, you will see an additional listing of all project IDs. But all Lustre Active is basically a directory of links. So a group is assigned, a group is assigned to either Storm or Cyclone based on what link is in Lustre Active. So as you can see on the right side under normal operations, if a user were to try and access the directory in Lustre Active Group A, they would be then linked to Lustre Storm Group A. And following that, if a Lustre Active Group B user were to try to access the group, they would just be redirected to Lustre Cyclone Group B. So we are able to control how those links are managed. And this helps us to determine where users are going to access their data, right? So users just use Lustre Active. They don't have to worry about the underlying file system. So if we decide to take down a file system, right, we just point all links to whichever file system isn't down. So if Storm's down, for example, we will have Lustre Active point Group A to Lustre Cyclone Group A and Lustre Group B to Lustre Cyclone Group B, and vice versa for Cyclone. So it's pretty nice. The users just have to use the Lustre's Active in their jobs, which is pretty convenient for them, and it allows us to determine where the users are at, and gives a pretty easy listing of where the users are at as well. How users are assigned to the file system is just using a hashing algorithm. They can be manually assigned to a file system, and this can change based on usage. So there is a little bit of additional monitoring of how users I/O and their usage patterns go. So there is a little bit of additional technical complexity there, but so far we haven't had to do too many changes for our initial user assignments. Following up with some additional workflow management. So initial job data is transferred into both namespaces from external sources on the initial part of the job. Compute jobs then choose which data to run on and where to export based on whichever file system is listed in Lustre Active. Following that, job output data is then replicated between file systems. This is chosen by the user, how much data they want to replicate, if they want to replicate data, and then exported externally. That's also chosen by the user, right? How much and where they want to replicate to. And then again, if file system maintenance occurs, replications are queued until the namespace is restored. So something to follow up with this. So as I mentioned, the user gets to choose how much and where it gets replicated to, and if it gets taken externally. And then when these replications are sent to a queue, depending on how long a file system it has been down, this replication queue can fill up and have a backup log. This backup log can, depending on how full this backup log is, can determine how long replication takes to flush to the other file system when the namespace returns back. Luckily, we do have some pretty great users. I'll keep that going. We do have some pretty advantageous users. So they will continue to check that queue and see and determine, is this data needed? Do we need to continue to replicate this? It's been in the queue for X amount of time. This is the job data that we really need to have. And they'll clear out that queue, determine if new data is really needed over old data, and allow us to reduce that amount of time for replication. One thing to also mention is that you can bring a namespace up, allow that replication data to occur, full queue to clear out, and then bring the other file namespace into Lustre Active with the links. So you can give yourself a little bit of breathing room there before fully returning that namespace into Lustre Active. So looking into some of the pros and cons of a setup like this. So one of the largest pros of something like this is namespace availability, right? So users don't have to care about Lustre Cyclone or Lustre Storm. They can just write to Lustre Active, and they don't care if we have to do a maintenance. They can continue to work and do their jobs and get output. As long as they do replication, they'll keep on working, and their jobs will keep continuing on. We have project level replication. So again, we mentioned we don't have to replicate the whole file system. We can reduce our amount of overhead traffic, and we're able to keep our replication to a minimum of what we truly need. One of the biggest benefits from a systems perspective, and additionally from a user's perspective, is all of our updates are non-blocking, right? So if we can take a namespace away, have the users work, they don't really notice. So this has enabled us to do some really phenomenal things. The users don't notice until the namespace comes back and they reap the benefits. So we've been able to do things like a Lustre 212 to 215 updates, rel 7 to 8 updates, DOM updates, and all within one leg down, one leg up, one leg down, one leg up, both legs up. So users don't notice until they receive the benefits. It's pretty phenomenal. So it's a nice system to have both high availability and to push out some pretty critical updates, even including security to users without interruption. One side pro of a setup like this as well is we have 3 different file systems, but it's all a homogeneous environment. They're all exactly the same. So if an issue were to occur with one namespace, right, we're able to identify that issue with that namespace if it's going to occur with the other ones. And I bug James a lot with whichever issue I have. We identify it, test it in our TDS, and roll it out non-blocking to our other 2 file systems pretty quickly following that. So we're able to identify issues very early on, right? We have 3 times the amount of area to identify them, hit them with the TDS, and roll them out with patches pretty quick. With every good, there's a little bad, right? So some of the cons, obviously cost, right? You have 3 namespaces with the size of 1, technically, if we're looking at the Lustre Active. You have the chance of having an imbalance of user I/O and bandwidth if you're not actively doing the study of how users are using the system. And if you're having a bunch of users that are very I/O heavy and they're all on a single namespace like Storm or all on Cyclone, and you're not rebalancing those users, you could have issues with those I/O contention there a little bit. So you got to be a little active and observe what your users are doing, what type of workloads they're running, and be able to manage that. So a little bit more technical complexity there. And additionally, just overall technical complexity, right? So you're managing 2 to 3 namespaces versus just one. So there's just a little bit more technical complexity there. And your outages, you're taking down legs, bringing up one versus just taking down a singular namespace. So a little bit more technical complexity there. And as I mentioned earlier, we do have the chance for some post-outage data replication buildup. We manage some of that with our users, but there is still a possibility that that takes a little bit longer. So some recent additions. As I mentioned, we were able to get Lustre 215 upgrade. That's been phenomenal. Thank you very much, James, for the help with that. That's allowed us to do some great things in troubleshooting, especially with networking, and a lot of performance upgrades as well. That allowed us to enable some great features such as data on metadata. So that's been great as well as we deal with a lot of small files. We've seen orders of magnitude increases in performances there. So our users have loved that. That's been a great addition. One fun thing with Lustre 215 is that we had upgraded the one file system to Lustre 215 and the other was still on 212 and had restored Lustre active. So technically you had a Lustre namespace with 215 and 212 at the same time from a user's perspective. So kind of an interesting little experiment how it looked, but it worked. So, the Lustre 215 people are probably pretty happy, but both are upgraded to 215 with data on metadata and running very well. Currently, we are working on and pretty close to our automatic failover of our OSS and MDS nodes. So with that, as I mentioned, both our OSS and MDS nodes have failover partners. Right now, that process, we can do that manually. We're hoping to have that implemented where it's automatically fails over those nodes, fails them over in the middle of the night, right? So if anything occurs bad, I'll fail over to the partner nodes. Clients can still communicate with that file system. So you have redundant access to your redundant file systems. I think that's probably my fiance's favorite feature, right? Because it gives me more assurance that I sleep at night. I don't get called. So very, very excited, very happy for that feature as well. So in summary, they are if you want to have a setup similar to this, just have 2 separate but identical namespaces. We have our users accessing data using links within Lustre Active. We are changing the links in Lustre Active in order to have our users work on a namespace. So we can work on a namespace, I should say, without interruption, and the users can continue to work on their jobs. And then we have our users send their data into both namespaces. And then upon job completion, they replicate however much data they would like to, and either internally or externally or both. With that, I'd like to open the floor for any questions, and I'd like to thank you guys for having me.
Where's my data? How have you trained them to look in the right places and understand that you've got this replication going, all that stuff? Seems like a hard problem.
So with our user, like I said, as I mentioned, the users manage the replication of their data. So by the time that we initiate a transfer over, they'll have a notification of, hey, we have a notification window, I should say, of we're going to initiate a downtime here, a downtime there. So when the transfer over does occur, that data is already there. So unless it's like an active job running, which they already account for, that data is already going to be there, right? They're already expecting to have that be done, and the transition time is just already there.
Maybe I'm just impressed you can train your users to do that for themselves.
We do have very good users.
Hi, Brian Olson from Oracle Cloud Infrastructure. My question is, or 2 questions. One is, how do you deal with unplanned downtime of one of the file systems? And then I can ask the next one next.
Okay. Yeah, sure. So unplanned outages for the file system. As I mentioned, we will have, with users, they'll have the data replicated across on job close is typically how that occurs. So when the file system does go down, if there is a current job running, there may be a job failure there occur, but when the next job queues up, most of our users that have those occur will automatically have a job retry upon failure. And then once that job retries upon failure, it will then relook within Lustre Active, see the new file system. It will see within the link, and then it'll just go to whichever directory, so that, sister file system within the new data.
Okay. Any concerns about overloading the single remaining file system in that case, or?
So thank you for asking that. So when we did the initial system design for both Storm and Cyclone, we designed for a single file system to support the capacity of all users on the system plus an additional X amount of percent. So we designed for a single file system to support all the users for a single leg.
Okay, so just sufficient headroom on.
Correct.
Okay. And then a second question is, what are you considering for the active failover, the automatic failover, like CoreSync pacemaker, or are you looking at?
Exactly. Yes. Yeah. We are using CoreSync pacemaker. Yep. Yes.
Hi, Scott Buckholz, Sandia. He sort of hit on that, but you were talking about how critical it was that the file systems were the same capacity. But if the users can replicate only a small percentage of their output data or whatever, why is that important?
So it's important for the fact of the matter that if we were to have the users be up at so say our users were to fill for example, say if Storm were to be at 5 petabytes and Cyclone were to be at 7 petabytes, if Cyclone were to be at 80% capacity and Storm and they were to replicate across, the users do have the ability to fully replicate across if they so choose to. If they were to do that and Storm were to fully replicate across, or Cyclone were to fully replicate across, and you would fully fill that file system, the users on Storm would then, in theory, not have a functioning file system. And if you were to switch to that file system in a file system down scenario, you wouldn't then have a functioning file system.
So it covers your worst case scenario.
Exactly.
Okay, thanks.
Kevin Harms Argon. Brad, did you mention what tools you're using to do the synchronization replication?
The synchronization and replication, yes, we have our users using Globus transfer currently.
Okay, so they would use I don't know if you have a wrapper tool or something. They just say, I want these files replicated, and then Globus does a transfer.
Yes, correct. All right, let's give Brad another round of applause.